this formula comes out to be very nice. What is the formula finally for horizontal force? Just pressure at center of mass times the area. Center of mass means center of area. So we can tell where is the center of mass located for both. And for each area, I can find out the force due to pressure. But on this inclined plane, what will be the force due to pressure? It will be this side.
Yes, sir, that will affect.
And one will be this side here. Perpendicular, because perpendicular. Now, this perpendicular force acting from water, it is acting from water inside the fluid. And it is also at the center of mass at h/2 depth. Same depth it will be for both. These are at same levels. You can start recording now. You can start recording.
I have started, sir.
These are at same levels. Okay. Now, from here, this force will become pressure at center of mass multiplied by what is the area for this. I think you understand this area will become h cosecant theta into b. Or we can simply say a upon sin theta. Or I can say PCM into h into, so why h upon sin theta? Because this length here, this L length is h upon sin theta here. This oblique length here, this length is h upon sin theta. Now we can also say that this pressure force due to pressure in the left hand side is pressure center of mass into area only, h into b. That is it. And what is the pressure at center of mass? Pressure at center of mass is equal to, or center of area, better term will be center of area. I'm using center of mass, but you understand it is center of area. Pressure at center of area will be equal to, pressure at center of area will be equal to P naught plus rho G into h/2, because it is at the midpoint, h/2 depth, into area. Area is h into b. Sorry, not area, just pressure at center of mass only. I'm writing this only. One more thing here. The formula will be valid even if we take cases of apparent gravity. Means if the container is accelerating, for accelerating container, in place of g, we will start taking g dash, which is apparent gravity. And other than that, one additional thing which you should know, all of you should know, that is gauge pressure here. Let me write down gauge pressure. Gauge, gauge pressure. Gauge pressure is just the excess pressure over and above atmospheric pressure. Excess pressure over and above, or we can say it is just pressure minus, gauge pressure will be pressure minus atmospheric pressure P naught. P naught I am using for atmospheric pressure. This we will call as gauge pressure. Means why do we take this gauge pressure? If I have, for example, if I have to write here gauge pressure, sorry, gauge pressure at center of mass of the area, or center of area, I can use the word center of area. Gauge pressure at center of area, gauge pressure at center of area will be into G into H by 2. In this P naught term will not appear, means normally everywhere P naught term will be there when pressure we are fighting. That pressure we call as absolute pressure at center mass. So means gauge pressure is equal to absolute pressure, which you already know, minus atmospheric pressure. Understood?
Yes, sir.
Okay.
Understood, sir.
It is like taking reference. We can think as if it is like taking, for example, you know that for potential we can take some reference, and all other points potential will become related to that only. Or maybe potential energy we can take reference. For example, if I take this line as a reference, and I say here potential energy is 0, then what will be potential energy H height above? mgh
MG
of some mass. And what will be the potential energy H height below?
MG
minus
H
MG.
height below will be
minus
minus mgh. It is something like this. If I assume some pressure at atmosphere to be 0, atmospheric pressure to be 0, then the pressure which is something greater than that pressure will be, I will call it as P only. Otherwise, normally I will call it as P naught plus delta P. But when I'm talking about gauge pressure, then with respect to this, it is delta P extra. And if it is delta P less than that, then it will be minus delta P. Okay, it is like P naught we are taking like reference. So gauge pressure can be negative, but absolute pressure can never be negative. You can write this point. Gauge pressure can be negative. Gauge pressure can be negative. And when it will be negative? It will be negative when P will be, if P is less than P naught. Absolute pressure is less than P naught. But atmospheric pressure, sorry, not atmospheric, but absolute pressure can never be negative. Absolute pressure can never be negative. If you are not understanding why it cannot be negative, you remember we derived the formula for pressure by this formula, N into M into V R M S square, I think, by 3, and here I think volume. You remember this?
Sorry,
Don't remember this, huh?
gases, no, sir.
We derived it for this case, no? That force is, it is colliding, the molecules are colliding to and fro.
Sir,
Then
we
if it
didn't
is L
discuss
length,
that, sir.
then I think I first derived the force formula M into Vx square by.
Sir, LU didn't.
Okay,
we not
sorry.
discussing.
Not for you, not for you. No, I understood. Sorry, don't worry. It is not required for you. I got confused because your parallel batch is running, no? In that same thing I was discussing, so I got confused. I thought I have discussed with you also. That will come later on. Don't worry. It will come later on. But anyway, means pressure is because of collisions of molecules. Pressure is because of collisions of molecules with the wall. So if there are no collisions, then no pressure, zero pressure. But negative pressure doesn't positive, because it is as I told you there, it is proportional to V square. So velocity means velocity of the molecules of the on curved surface. Although it will not be tough, because you have understood. I think some of you may have understood by now also. You remember, so see here. Last time when we got this force is inclined at an angle. What angle it is? It is theta. Then it
90
will
minus theta,
become
sir. 90 minus
90 minus theta, I think, with horizontal. Let us consider,
90 minus theta only.
let us consider 90 only. Then this is force F. What will be FH? What will be horizontal component only? Horizontal component will be FH, horizontal component of that force.
PCM into A, sir.
That will
F
be
sin
F
theta.
sine theta again. So if I multiply by F sine theta, then I get same force as,
H into V.
means the horizontal force on the left wall and on the right wall is same. And I told you why is it same. Yesterday I told you a little bit. I told if it is not same, then its reaction on the water will not be same. And if reaction on the water from left hand side and right hand side, then water cannot remain at rest. Can it remain at rest?
No, sir. It will move. Yes.
It will move. But we know water is at rest. It means the horizontal forces are balanced.
Balanced.
Therefore, whenever they are asking force on any inclined surface or on any curved surface, I will not find out in the curved surface or in the inclined surface. What I will do, I will make a corresponding plane surface. I will find force on that vertical surface only. And whatever force is acting on that vertical surface, same force will be acting on the surface which is curved or surface which is not vertical. Force will be same. I can give you one example for this, then you will understand it better. Let us take one container again. Let's say this is a container, and in this container, in the side wall, there is some curved surface. How to make it? It is a spherical curved surface protruding. It is hemispherical. We can say it is hemispherical curved portion in the wall. Let's say out of the complete wall, we have one hemispherical curved portion, this type. And I want to just find out, is it 2D okay? Because 3D will take a lot of time. I think you understand in 2D. It has,
Yes,
it is
sir.
something like this.
Yes, sir.
It is something in this way. If I look from the side view, it will be something like this. Okay, fine. Anyway, so on this curved portion, if I want to find out the force, what I will do first? First, I will take the vertical area. How to take the vertical area for any curved surface area? Let's say this is a curved surface area. How to take a corresponding vertical area? What I will
Base.
do here, I will just draw
Skill area, sir.
I will just draw some, I will put some rays, horizontal rays, and I will make a vertical wall. I will put some horizontal rays on this curved surface and I will make vertical wall. Then I will get some shadow. That shadow will be the corresponding vertical area on which I want to find out the force. You can take any random curved surface, any surface area, any subsurface area, let us say. But if I take a vertical plane and I put a shadow on this, on one side, okay, and whatever the shape of this area may be, I don't know what is the shape. It may be some complicated shape. But finally, when we get the shape of this in a flat surface, then that area will be the area on which I want to find out the force. Simple. So it is very simple to find out the ellipsoidal portion. Ellipsoidal means something like ellipse with a semi-major axis as B and semi-major axis as A and semi-minor axis as B. Then what will be the area on the vertical wall? If I assume it is a ellipsoidal, semi-ellipsoidal surface, then the area on the vertical wall will become pi into B square area. And here it is just for the
Pi into R
circle, it
square.
is just
Pi R square.
pi r square for hemisphere. So for hemisphere, it is pi r square. Then what is the force acting on pi r square area? If I want to find out, first of all, in this container, you should know how much deep the center of area lies. Center of area means center of circle will be the center of the mass of the circle. So that will be lying at what depth? Let us say this depth is given to us by this method. This is given radius r, and it is, sorry, this distance is also r, this is also r. So total becomes 2r. Then I can say pressure here will become, gauge pressure will become, what is the gauge pressure? Rho g to r, that is the gauge pressure. And what is the force acting from inside? Horizontal force acting from inside will be equal to P naught plus the gauge pressure, that is the net pressure at the center of mass, multiplied by area. Area is pi r square. So we are getting it so fast, so easily. Actual force is so complicated. How can we get otherwise? We can get by integration. If I do the integration, then also we can get. But then I have to take some ring elements. On each element, I have to find out the force, and then I have to integrate. And we can do all this without integration directly by writing this formula, P naught plus rho g into 2r into pi r square. What will be the force acting on this curved portion due to pressure? Total pressure, I'm saying, not only hydrostatic pressure, due to the pressure outside and as well as inside. What is the pressure from outside? I think you know that outside is atmosphere. So pressure from outside will be P naught. So due to that, it will be P naught into pi r square. Then what will be the net force? Net horizontal force due to the total pressure will become P naught plus rho g into 2r into pi r square in one direction, I cap, minus P naught into pi r square in minus I, this is along minus I cap. Then what we get finally total? Then total is only rho G2R into pi r square. Means what is the difference between this and that? This is only due to liquid inside the container. Liquid inside container. What about this one? This one is due to pressure inside and outside. Outside is only due to, outside is due to what?
Atmosphere.
Atmosphere. And inside is due to what? Inside is due to liquid. So when we take atmosphere also into account, then see, it is ironical. When we take atmosphere into account, then there is no atmospheric pressure term appearing here. You see here, when we are taking the pressure due to atmosphere, then atmospheric pressure term cancels out. But when we take only due to liquid, then atmospheric pressure term is there in that. When we take due to both, then atmospheric term is not there. That will get cancelled out. Then the pressure, the force is only due to gauge pressure. This is one point where I cannot give you the exact answer. If there are 4 options given,
Sir, in a closed
if they give us,
container, atmosphere pressure will not be applied. No, sir. Full.
no, not like that. It's not a closed container. See here, this is open container. Here P naught will be there in this. It is open container, and this is the water here in this. Okay, it is open container. I understood what you are saying. That is different thing. When it is a closed container from all sides, then will the atmospheric pressure be there
No,
or not?
sir, only
Let me
gauge
give you a very simple logic here now. Let me tell you one thing. Let us say you have a glass full of water. You have a glass full of water, and you are taking a cardboard piece and you are putting it on the top of it. Do you think now atmospheric pressure will suddenly become 0 because you are putting a cardboard on the top of it? No, it will not
No,
become
sir.
0. With what pressure it was already filled up? It was, listen, let me finish, please. With what pressure it was initially filled up? It does not change. It does not change. When it can change? It can change in this way. Let us say I have a closed container again, closed glass, and in that there's a piston on the top, and inside it there's a water. And now I apply some extra force on the piston. Then the pressure will now become different from the atmospheric pressure. But just by closing a container, we cannot ensure that the pressure will not be. If I just close a container, then at the highest point, the pressure will still be equal to P naught. At the highest point of the container, the pressure will still be P naught. So just by closing a container, we cannot say that pressure is not P naught. And what is the highest point here? Highest point again, apparent height. What is meaning of apparent height? For example, if I take this side with acceleration A, then pseudo force will be acting this side, MA, mg will be acting downside, then apparent gravity will be this side, mg dash. Then you can take a line passing through center L in the direction of g dash, and you produce this line further. Then this will be the topmost point here. This will appear like topmost point, and this will appear like bottom, apparent bottommost, apparent topmost, apparent top, and apparent bottom. It is like apparent bottom, just apparent, not real bottom. Real bottom will be this only, obviously. It is apparent bottom, and it is apparent topmost point. So what happens as a result now? As a result, this point here can be atmospheric pressure point here. If while we put the water inside it, when we put the water inside it, at that time it was filled with atmospheric pressure in the top, then it will continue to be atmospheric pressure in the top. But if we fill it with some extra force, the way we fill it, the tires of the vehicle are not filled with atmospheric pressure. Those are filled with higher than atmospheric pressure. So there the pressure will continue to be that higher than atmospheric pressure. So in closed vessel, what is the pressure? We don't know really. Sometimes it may be atmospheric pressure. Sometimes it may be some other pressure P at the topmost point. If here it is P, then what will be at a depth H? Depth means what? Again, what do we mean by depth? As I told you before, in the direction of vertical, this apparent vertical. In that direction, when we go, then
P plus rho GH.
lines perpendicular to that will be apparent
Same
horizontal
pressure.
lines.
Yes.
lines, yes, these are same pressure lines. And when we will be moving in these lines in this direction by some depth h from this place, here it is p, here it is already p at this point, I'm assuming it to be p, then what will be h depth below? H depth means h apparent depth below. I hope you understand now. Rho into g dash into h. What is g dash? G dash is equal to g square plus a square under the root. By this we can get, I think, because it is mg, it is ma, it is resultant. So I know how to find out the g dash value. That will come out to be g square plus a square under the root. Is it clear?
Yes, sir.
Right. So what is the pressure in a closed container? We don't know. But will the pressure change, increase in closed container also as we go in the direction of gravity, or
Yes,
as we
sir.
go in the direction of apparent gravity? Yes. In the closed container also, pressure will increase in the direction of apparent gravity. But if the container is containing liquid, not just gas. If it is containing just gas, then as I told you before, because gas has less density, and if gas has less density, then this rho term will be negligible. Then overall the pressure will nearly remain same, only for gas. But if it is filled with water or any other liquid, so pressure will be varying. Understood? All right. Let me ask you another question now. In a container, let us say this is a container, and in this container I have a handle. You know what is the shape of handle?
Yes, sir.
Yes, sir.
Like a we can say like a we use word torus for this. If we have such shape, wait a second, not like this. How to make a torus? I
And
think
cylinder.
this way,
Semicircular tube.
something like this. Like a tube, like a tube. It is like semicircular tube. Yes, that is better. Or semicircular donut. You know donuts, right?
Yes, sir.
Yes, sir. Yes, sir.
So it is semi donut. It is half donut or it is half tube. You think like that. It is half tube. So in this half tube, this is the half tube here, and we want to find out what is the force exerted on this tube due to pressure from the liquid. How to find out the force exerted in this tube due to pressure from the liquid? I have to tell you some data here. This upper part is circular, and the lower part is also circular, and that lies at a depth from the top, and the center of lower circle lies at a depth h2 from the top, and radius of each of these same circles is r each. Then what will be the force? Now, if I take the projection on this, if I take the projection on this here, and from this side also pressure will be acting. Pressure will be acting from both sides, but on this circular area portion, only it will be from one side. So overall force will be only on this area and on this area. That we can think. Because on the remaining portion of the tube, if I take and the force will be cancelled out, and that's 0.
Yes.
On which force will be uncancelled? On this portion here. On this portion, the force will be one side, but from other side there is a wall, and there is no liquid on the other side. Liquid is only on one side. Therefore, the force due to liquid will be on these areas ultimately. So, what is the force due to liquid on these areas? That is how we will take the projection. This is at a depth h1. Center of it is at a depth h1, and center of second one is at a depth h2. Then start from the top. At the top, it is, let us say, p naught. It is filled up to the top. It is filled up to the top. Then p naught plus rho g h1 into pi r square. Second case I took for the oblique surface, inclined plane. then also whatever is on the inclined plane, same is on the vertical. See, if I take inclined plane, in this also you can apply the method of rays. Take the rays on that incline and then take a vertical plane. Then what shadow it will form? It will form the shadow which will be equal to this yellow shaped area. Even if I take the shadow of this pink area, then on the vertical plane it will form like that of yellow. Same force will be acting on this pink area in horizontal direction. That also we can say. So horizontal component of the force is always very easy to determine. We can determine in this way. Next, one more case is left. I think I will take that case. No, that I will not take now. Now that is not required. Now we have to do vertical forces. Vertical forces on due to pressure. Vertical forces due to pressure. Okay. Hydrostatic pressure is better term, although, because we are all, but in this topic is itself fluid statics. So if I'm not saying that, you should understand that we are talking about fluid at rest. We are only talking about that. Hydrostatic pressure. Hydrostatic means it is whether it is gas or it is liquid or whatever, or it is water, but it should be at rest. Static is important here. So to find vertical forces due to pressure, let me take again one example. Although this example I have started with this example in the beginning. Let me go back again. This example, you remember this example? Initially, when I have drawn the free body diagram, then some of you, I think what somebody told me at that time, told me, sir, it is coming out to be same as the buoyant force. It is the buoyant force only. The vertical force we can consider like a buoyant force. But I told you how to find it out. How to find out the vertical force. This is a method to find out the vertical force. If I want to find out vertical force on this portion, what will I do? I will take equivalent, and in that at the same depth, I will make the same diagram. But this will be completely filled with liquid without any such solid portion. Completely filled with liquid, and on that completely filled with liquid, I will find out the I will draw the free body diagram, and I will find out the force on that portion, and same force will be acting on this portion. So vertical force will always be equal to the force of the liquid displaced. Simple. And that we also call as what is another name for that? Another name for that
Archimedes
is just
principle.
buoyant force. What is another name for it? We just call it as buoyant force. Now, right, vertical force is due to pressure. So I think one example I had already taken, but this time I will take a different, more difficult example. But if you understand the concept, you can do this also. Definition? What definition?
What a vertical force is due to pressure? You told no suggestion.
There is no definition. I am saying how to find the vertical force. I am saying take equivalent container, find out the force due to pressure in that equivalent container. What equivalent container? Equivalent container just filled with liquid. Why are we taking equivalent container? If you do it once, you will understand why we are taking the equivalent container. The idea is this, that let us say I am asking you this question now. This is a hemispherical portion. It is a hemisphere. It is a hemisphere. What tension is acting on it? T tension is acting upwards. what is the force acting on it? Let us say we want to find out the force due to pressure. Find force due to pressure on the and curved surface area of hemisphere. Density of liquid is given as rho. Now, see, I'm giving you some time to think over it, think about it, and try to get the answer. Radius is given as r, rho is given, r is given. Tension is not given.
The depth also not required.
We don't need any other thing. Just now you think about it. Think about it. I already gave you hint also that you can go back and see that diagram how I did it at that time. That hint is enough for you. So I'm giving you nearly 2 minutes time. By that time I will be just making it properly.
Sir, rho into
How to find it out?
Your mass
rho into 2/3 pi r square into g.
That is first answer, I think, right? To find it out, see, those who are still not understanding how to do, let me tell you how to do. I'm copying this diagram, and this is the diagram for solution. But this, sorry, what happened here? While I want to make the solution for this, that if the diagrams are identical and we are at the same depth, then pressure at the same depth will be same in the upper diagram and in the lower diagram, because pressure just depends on is getting applied on the upper one, same will be applied on this. Although in the lower diagram I'm not putting any solid there. There is no solid here. It is just liquid in the liquid. It is total liquid container only. There is nothing special in this. Just a liquid container, but I'm making imaginary sphere there, imaginary hemisphere. And on that imaginary hemisphere, I know the force acting on that imaginary hemisphere will be same as force acting on the solid hemisphere. Reason? Because force is only due to pressure. Let me correct myself again. I am saying force acting on the solid hemisphere due to pressure and the force acting on the liquid hemisphere due to pressure will be same, because these are at the same depths. Force acting on solid hemisphere due to pressure is same as force acting on an identical water hemisphere. Force acting on solid hemisphere plays in water. Force acting on solid hemisphere plays in water due to pressure exerted by water is same as force acting on an identical water hemisphere placed in the same location. Not placed. It is not placed. It is already there. And it is easy to determine water hemisphere. Why it is easy to determine the force due to pressure on the water hemisphere? Reason is that here we know what is the weight of the water.
Yes.
Weight of the water is rho into 2 by 3
Pi r cube into G.
pi r cube
Cube.
into G.
Pi r cube into.
And other than that, whatever force is other than that, that force is only due to pressure acting above as well as below. I don't know what is the pressure. Although pressure is variable and I don't even know because I don't know the depths. But you see how wonderfully we still get the same result. That force due to the net vertical force due to pressure will be just equal to rho into 2 by 3 pi r cube into G. So we are getting answer for the first case easily. For second case, we cannot get answer. I need more information for that. Let me give that also. For second case, I need this information or any other distance I could have given. I'm giving this height as h. Up to the bottom base of this, I'm giving height h. If I know that height h, then what will be the area on the plane surface? Now, area on the plane surface, I can calculate from here. What is the area on the what is the force on the plane surface? The force on the plane surface is P naught plus rho G H times pi r square. I could use directly this formula because pressure at horizontal place, in horizontal plane, pressure everywhere is same. So pressure into area I can directly write. I don't have to integrate also. But do I know what is on the curved surface? No, that is not known till now. But I also know, let's say this is the force on the curved surface area, CSA, curved surface area. CSA means curved surface area. And this is due to pressure only. It is due to pressure only, nothing else, just due to pressure, not the tension. I'm not drawing the diagram of that. I'm just drawing the diagram of liquid within the liquid. But we also know what is the net vertical force. Net vertical force due to pressure. Net vertical force due to pressure, FV, is equal to, obviously what it will be now, net vertical force is upwards, because I know the from bottom the force will be more, from above the force will be less. How I know that? Because the pressure increases as we go down. Therefore, this force will be more due to pressure and this force will be less. So the net vertical force will be upwards. That is net vertical will be equal to, sometimes I will call it just as F1, and this total I will call as just, let us say F2. So what will be the net vertical force upwards? That will be upward force F2 minus downward force F1. That will be F2 minus F1. So what is that finally? I know the vertical force is equal to rho into 2 by 3 pi r cube into G. and that is equal to what?
P naught G H.
F2
P naught
P
plus
naught
rho G H
plus rho G H
into pi r square.
whole into pi r square minus the curve surface area or F1. So what is that F1 coming out to be from here? Calculate
For
and
second case, we need
let me
height,
arrange the
sir.
diagram and you please calculate yourself only by that time.
Sir, for second case, we need a height, no, sir. Mean depth.
We need height h. H is given to us. Assume h to be given. Okay, assume h to be given. Without h, we cannot determine. I forgot to mention in the beginning, but I should have given h also. Otherwise, we cannot determine the second case. That is correct. Even if I ask you the question, only find out force on the curved surface area, you have to still find out the total, and then only you can find out on the curved surface area. Why? Because once I know the total vertical force, then only by this equation I can get the force on the curved surface area also. Okay, so that net vertical force I still need to find out, even to answer the second question. What is F1 coming out to be? Do the calculation, please. Tell me finally. Minus rho into G into pi r square into
Sir, pi r square into P naught plus rho G H by 3, sir.
I am getting this. Is it
Yes,
wrong?
sir. That only. I said.
That only.
Yes, sir.
You also said that. Okay, you wrote it in a different way. I understood. Okay, how are you writing it?
Taken
You're
pi
writing
square
it in
common, sir.
this, and then it is becoming pi. No, we cannot do that. That only we have to do. I don't know what you were up to. Minus 2r by
Yes,
3
sir.
only.
Yes, sir.
That one. So one more thing here I want to say. Sometimes you got the answer. Okay. Let us say you got the answer. Wait a second. Wait a second. Is it right or wrong? Plus or minus? Plus. Plus only. It is plus here. Because F1 comes this side, it becomes positive. This went that side, it becomes negative. Okay.
Okay, sir.
So now, one more thing. Let us say options given are different options where there is no P naught into pi r square term given. They are asking find out the force on the curved surface area. But answer given is only rho g into pi r square into h minus 2r by 3.
We are
And in
asking
no other
about
option
gauge,
you are finding anything related to P naught. Pressure?
gauge pressure.
Gauge pressure. It means he's asking the force due to the gauge pressure. So it happens sometimes. They say find out the force due to liquid, but they don't take the atmospheric pressure into account. So that we have to do. We cannot do anything in that. If they are asking force due to liquid, but they are not considering P naught, it is a general convention. Sometimes people do that, and that convention is also not followed properly in all the books. Some will follow different conventions. So therefore, if you find something contradictory, you understand, quickly change your mind and understand. Don't think that no, I should not attempt this question. No, attempt it. And if there is no P naught term, leave it. Don't forget it. At least this is there. Then go for that. But when this is also given and this is also given, and in one case only this is given, then I will consider this total to be the better option, because this is the net force due to the pressure. Okay. But if only one of these is this one is not given, and Okay. Understood?
Yes, sir.
Yes, sir.
Right.
Understood, sir.
So next we have. So, and one more point I'm asking you to remember that even if they ask to find out on the curved surface area, don't get confused. First, find out what on the solid total. After that, on the curved surface area. And how to find the total? That we find out again changing the diagram for the. We will draw the diagram of liquid container only, and on that liquid we will find out. Same way on the. Okay. So after that we will get, means in these cases also. Let me change the example now. If in this example I ask you to find vertical force, how will you find out? In asking on the pink area to find out the vertical force, then don't find the vertical, you find out the net force. How to find the net force? On the plane area, always use formula PCM into area. What formula we have to use on the plane area? PCM into area. Whatever area it is A by sin theta, then PCM into A by theta. I found that on that, then take the vertical component also.
Into
F sin theta is horizontal, vertical component will be what?
F
F vertical will be just F
cos theta.
cos theta. Okay.
Yes, sir.
Vertical force on pink area. Vertical force
F
on
cost.
pink area. That is F cos theta.
Yes,
Okay.
sir.
Yes, sir.
And now come to this question. Let us say somebody is asking you to find out vertical force on this protruding hemispherical portion. This is although portion of wall only. There is not a solid object inside. We have not kept anything inside. It is just a wall, and wall is itself curved. Even if wall is curved, on that wall also there will be some vertical force. So how to find out this vertical force now? How to find out this? Again, assume a total vertical container. Assume we have a vertical container like vertical with vertical walls. Assume we have a container with vertical walls only, not such walls. Then whatever is the force acting on that solid hemispherical object, same will be on this portion also. And how to find out on the solid hemispherical object? What is the rule for that? I told you the rule for that is assume there is no solid hemispherical object, but instead of that, it is just completely filled with
Liquid.
same liquid everywhere. If it is completely filled with same liquid everywhere, then what will be the free portion? Then free body diagram of this liquid portion will be this vertical this is there, and this is that liquid portion for which we are drawing the diagram. How the force connect on it? The force connect on this from pressure due this side. What other forces connect on it? Due to its weight, that is rho into 2 by 3 pi r cube into g. What is the force from the curve on the curved surface area? On the curved surface area, from the below, the pressure will be more. These vectors will be bigger, and above the vectors will be smaller. Above the force will be smaller, and as we keep on going below, the force will become bigger and bigger. So net force on this will be vertically upwards. So what is the resultant? Resultant will be something like this. Vertically upward force will be there, F vertical, and horizontal force will be there. Let us F horizontal. What about force from the wall?
None.
What will be the force from
It
the wall?
not, sir.
This side.
Yes, sir.
Yes.
And it is acting on what? It is acting on not on solid. It is acting on the
Liquids
liquid
around it.
portion. On liquid, if it is
Liquid
means it is
portion.
completely filled with liquid. If it is completely filled with liquid, then it is completely filled with liquid, and on liquid every the force due to pressure will be, and effectively resultant of that will also be single FH. The horizontal force will be balanced because I what is the vertical force this on the plane surface area. You have not learned the one most important thing in this chapter. One most important only. If you want to forget everything, just remember one thing only, and that is this: that tangential forces don't act on the liquid at rest. It is a liquid
Yes,
at
sir.
rest. We are not drawing the diagram of the
The
solid. We are drawing
tangential
the diagram of
forces
the
are
liquid.
acting.
And on the liquid at rest, there cannot be force in this direction because it becomes parallel to the area. It becomes parallel to area, and that cannot happen. So F dash vertical on this plane surface area, there will not be any vertical force. Remember it. This is one thing we have to remember. There is no, because this force acts like a friction. Remember. Ashraf Khan, please be silent. Ashraf Khan. Ashraf.
I can't even mute him.
I can mute him, but I want them to know also that are they attending the class or they are just. I have to remove, otherwise if he is not listening also and he's just wasting time on. Okay, no problem. I mute already. Anyway, I was discussing about this, right? Remember, there means just remember one thing. There is no friction. If you don't want to remember tangential force, there is no friction like force. There is no tangential force on liquid at rest. On the fluid at rest, there is no friction like force. What like force is there? There is force like normal, but there is not force like friction. There is a force like normal, means the force like the force due to pressure is like force due to normal only, because normal also acts in the same way only, no? Normal also acts
Yes, sir,
perpendicular.
same
So
way.
the force due to the pressure is like force due to normal, and there is no force due to friction. There is no tangential force acting. Okay, if you can remember this thing. And second thing you have to remember, that when we are drawing the diagram for the any solid part, then first we will imagine a container or the curved walls. We will imagine a container with vertical walls, and in that container with vertical walls, we will fill this wall entirely with, we'll fill the container entirely with liquid, and on that portion we will find out what is the force acting. That same force will be acting on this curved wall also in vertical direction. So what is the answer now? Tell me, what is the answer on this? What is the vertical force of this? Vertical force is just equal to the weight
Rho,
of that
yes.
curved portion, protruding portion, that is 4 by 2 by 3 pi r cube into rho into g. Simple.
G. Yes, sir.
This is also called as buoyant force, the vertical force. Horizontal force we don't call as buoyant force, but vertical we call as buoyant force. This also. What is the vertical force on this part? Let us say it is a, what is the radius of this? This yellow, this red color radius. This radius I can find out by knowing the diameter. What is the diameter of this? Diameter will be h2 minus h1. h2 minus h1 is diameter. Then what will be the radius? Radius will become h2 minus h1 by 2. That will be the radius. Let us call it small r. Let's call it small r, because capital R was another radius. What was capital R radius? Capital R was radius of the tube, radius
Yes,
of cross section of the tube.
Yes, sir.
That was capital R. Okay. Then what will be the vertical force? If you know what is the volume on this in this portion,
2/3 pi r cube minus small r.
then you can find out the weight of this portion. And if you know the weight, rho into V into G, then you know same will be the vertical force. Propose theorem says that if I form any surface by rotating some plane surface, if I form any surface by rotating some plane surface, then the volume of that surface will be equal to the path length covered by the center of mass multiplied by area of the plane. What is the area of this plane? Area of the plane, which is this tube, we can form the tube by rotating a disc of r radius. By rotating a disc of r radius, we can form this tube. Then pi r square is the area of the disc multiplied by path covered. Path length covered will be, by the center of mass we have to find the path length covered. That will be pi into small r. It means it will become pi r square into pi into h2 minus h1 divided by 2. That is this. That is the volume. Then what is the vertical force? Then the vertical force just comes out to be equal to rho into V into rho into pi r square into, again one more pi square r square into h2. That is it. That is the vertical force. So we already knew what is the horizontal force. Now we know also what is the vertical force. I can ask another question. Indirect question it will be. What is the force applied by the wall, this wall on this handle? Then we know, because the handle, this thing is at rest. This tube is at rest. So what will be the force applied by the wall on the handle? We know the force due to the pressure is vertical force, and we know the force due to the pressure is also horizontal force. Horizontal we know, vertical is rho into pi square r square into h2 minus h1 by 2. Horizontal is equal to rho into this already I have written here, big force. I will not write it. I will just write FH I know. Other than that, let us say this tube has some weight. Its own weight is there. Let us say that weight is mg. The mass of the tube is m. Mass of tube. That weight we know. Then what will be the force applied by the wall on it? So these forces, overall this tube is at rest. So whatever remaining force is, that remaining force will be the contact force. But I know that it will have two components. One will be horizontal force and another will be vertical force. But the net force will be definitely equal to the
Horizontal
remaining.
force.
The net force will be definitely equal to 0. Then I can find out what is the force applied by. Then I can find out what is the force applied by the wall on this tube. That also we can do.
Vertical force will be there,
Yes.
sir.
On
that,
which?
Contact surface. Sir.
Yes, there may be some vertical force. I don't know which direction it will be, but it will be something.
But here vertical
Sir,
force,
but it's
Fe and this
parallel
Fg
to
are
plane, no?
cancelling out now, sir.
Tangential.
No, applied not. Oh, listen, please. Don't talk, please. Let me finish. What are you even talking about? Vertical force on the tube I am finding. I'm not saying I'm not saying vertical force on the liquid. It is not liquid. It is a tube, solid tube. On the solid tube, there will be vertical force or not. Due to the
Yes,
buoyant
sir.
force acting upwards, this is not moving upwards. It is still at rest there. Let us say, okay, wait a second. Let us say I made a tube of wood. Will this wood remain here only, or will it start floating up?
It
Will
will
it
go
start
up.
floating up or
Float,
not? If it is made of wood. But if it is not floating up, it means the wall is applying some force on it, which is making it fixed there. So wall has to apply on this fixture. The force is applied by the wall in downward direction or not. It can apply. Maybe downward or maybe upward. I don't know. Depends whether it is a wooden tube or it is a some heavy tube made up of iron. If it is a heavy tube made up of iron, then this will try to sink.
And
But
upwards,
if
sir.
but the force is yes. So that force has to be there. I'm not making the diagram here while I'm saying that what force is acting on this solid. Then at that time, I'm not saying the force is acting on the liquid portion of it. On that liquid tube, what is the purpose served by that liquid tube? Purpose served by that liquid tube is only to find out this vertical force, which I found already. What is that? 2 pi square r square into h2 minus h1 by 2 into g. I forgot g into g.
Understood.
That is also there.
Understood, sir.
This is a force acting. But it does not mean if I found by the taking the liquid free body diagram, then I can never draw the diagram of the solid. I can draw the diagram of solid. In all these cases, I can draw the diagram of solid. In the first case itself, from where I started all this discussion, here, not that. Where was that diagram in the, okay, I think it was in the beginning. In this place also, I'm prohibited to draw the diagram of the solid. I can draw that diagram, but this diagram I have drawn for the solid also. But unfortunately, in solid, what is the and sigma was also unknown. Sigma was unknown. T is also unknown. Both were unknown. And there are two unknowns. We don't solve it. Therefore, I made the identical diagram. There, the tension is not appearing. and I could get the value of P2 minus P1 into A square directly from there. And that I will substitute back in this. I think in this case, P2 and P1 were unknown, and I was able to find out. No, in this case, everything was unknown. P2, P1 was also unknown. T was also unknown. Sigma was also unknown. So it is a diagram full of unknowns. I don't. It is not useful diagram for me. But when I draw the diagram for identical liquid portion here, then the things became so easy for me. Just one unknown, and I got the answer quickly. Rho
There
was
is
known,
no
and this
tension, sir. Yes.
no need of tension, no need of knowing P2 and P1 separately. Just P2 minus P1. But it does not mean I should not draw the diagram of the solid. It does not mean that. In the beginning, it is convenient for me to draw the diagram of liquid, but it does not mean I should not even draw the diagram of solid. So there, after finishing the diagram of the liquid, I went back to the diagram of the solid tube. And while drawing the diagram of the solid tube, then I got this conclusion. Where was I? Wait a second. Where was that diagram again? This tube diagram.
Below that, sir. After this.
Here it is. So while I started saying here, then I started saying here that the wall will apply some force. Then it means that wall is applying force on the solid tube. I'm not saying it is applying force on the liquid. Understood?
Yes, sir.
Okay.
Understood, sir.
Yes, sir.
Right.
Sir.
Yes, sir.
Next thing now. Let me take one more example, which is again different, slightly different. Find out the force on this in vertical as well as in horizontal direction. On what? When I am saying force on cylinder due to pressure, it means I am saying net pressure. Then I have to take only gauge pressure because P0 will cancel everywhere. So what pressure I have to take now? Just the gauge pressure. The liquid is filled up to the level of the center of this cylinder, and it has width of the container is, height is h, up to which the liquid is filled. We don't need that, although why should I give it? No need. Width is needed here. Width is b. One wall is having this cylindrical portion above, right? Something like this. And width of this is b. Something like
Yes, sir.
means water is touching only one side of this cylinder, but it is not touching the plane surface areas. It is touching only water is only, liquid is only touching the curved surface area, and on that curved surface area we have to find out the force. On plane surfaces it is not touching, from this side or from this side it is not touching. Even if it touches this side and this side, that those forces will get cancelled out. Okay, so finally force will be only, uncancelled force will be only in this side. Find it out. And by that time, let me make another diagram for other question. You do it yourself by okay.
Sir, horizontal force is rho g r square b and vertical force is 1/4 rho pi r square bg.
Yes. Now, what is your answer? Say it again.
Sir, vertical force is 1 by 4 rho pi r square bg. And horizontal force is rho g r square b.
Correct. Exactly right. Because if I take a vertical, first I will take a vertical cylinder, right? Like this vertical, completely with vertical wall. Then this portion,
1 by 4.
this portion is water displaced. Then this is 1/4 of the cylinder. 1 by 4 pi r square into rho into b also into b width, that is volume, into rho into g. Correct. That will be the weight of this portion. And once I know the weight of this portion, then that weight will be balanced by the vertical force. So, and that vertical force will be, and there is no vertical force acting on this this face here. There will be no vertical force here, right? And here only horizontal force will be acting, and that horizontal force acting on this part will be balanced by horizontal force acting on the curved surface part. So, what horizontal force acting on this part? That will be obviously now, as you told before, that will be equal to on vertical area. It will be. I think you said wrong. What do you say? Say it again.
Rho g r square b, sir. That rectangle
Rho g r square into
b.
b is wrong. Wrong. Wait a second. Rho g r by 2. That is the pressure at the center of the. This vertical area will be a rectangular area, and in this rectangular area, the center of this will lie at a depth of r by 2. Then this is the PCM value.
Understood, sir.
This is PCM value. You are taking rho g r. That is wrong. Into r into b. Into r into b. So PCM here is not rho g r. PCM is rho g r by 2. Understood?
Yes, sir. Understood.
Up to center of mass only. Up to center of mass only you have to find out.
Understood.
Okay.
Sir, one still vertical.
What
sir.
about the others? Yes. What?
One still vertical.
What are you
Sir.
asking?
Vertical force.
Vertical will
Vertical
be.
force, sir.
That's what I mean. Vertical will be obtained by taking the what I told you. What is the method that I have told you? What method are you following? Now I should in fact find out the mistake committed by you, because method is clear and it's straightforward. Just imagine always the wall with vertical. Take vertical walls. This is a curved portion in the wall. Vertical, exactly vertical. And then I will find out. I will put the entire container with the liquid, and then in that I will make that shape again within the liquid only. And on that I will find out the force. It is as simple as that.
Yes, sir.
So if you are still not getting it, it means I don't know what you are doing. But this is a straightforward method. I'm just telling one method only. That follow always this method. That will always work. And if you are not following that, then I don't know what you are doing really. I want to now see what was your method. Always straightforward only. Just make the wall vertical. The wall was ending here. I will make it vertical up to this complete container. Up to the I can make it up to vertical up to infinity also. No problem in that. I can make it vertical up to infinity, and then I can imagine that in the same the water is filled up to the same height h. Then and it is just a wall which is extending up to infinity. Then the water will automatically come up to this place. It will be filling up this part also, and if it fills up this part, then on this part I want to find out the weight, and the vertical force will be just balancing the weight of this water. Why the vertical force on the curved surface is balancing this? Because if I take why I'm taking vertical walls here. so that there is no force applied by this wall. This wall will not create any difference. This will not apply any vertical force on it. It will apply only horizontal force. As far as vertical forces are concerned, existence of this wall or absence of this wall doesn't make any difference. Horizontal force, but it cannot apply
Horizontal
any.
force.
It cannot. Okay.
Yes, sir.
Do the second one now. Do one thing actually. Take the snapshot of this question. Taken.
Yes, sir.
Yes, sir.
Do this one. What is eye touch? Okay, I'm giving you a hint how to do. Just balance the force on the piston. Balance the force on the piston from left hand side and from the right hand side. You will get answer quickly. Do that. By that time, let me make another question here. You note it down so that because I will change the diagram, I will shift to another page. You please note it down and keep attempting it yourself.
Sir,
Yes.
I'm getting height as R1 into
Getting answer?
R1 into R1 by R2 whole square.
You are doing it wrong. Because it is a closed part here. But this part I know the pressure. Start from here. I know here pressure is definitely and definitely. Just tell me what? P naught.
P naught plus
P naught.
Sir, P
Then
P
here
naught.
at a depth, it will be P naught plus rho GH.
Rho GH.
And here also it will be same in the
Same.
same horizontal level, same.
Rho GH.
So P naught plus rho
Sir.
GH. Then what is the pressure at the center of this? Pressure center of this will become P naught plus
P naught plus rho GH.
H minus R1.
PCM into area will be equal to P naught into area. Area gets cancelled. This, see, from the left hand side it is P naught into area. Everywhere it is P naught. It is atmosphere. It is open to atmosphere. And from the right hand side it is PCM into area. PCM into area. Is it okay?
Yes, sir.
Sir, God, sir.
Okay. Then what is PC? Then what is H value coming out to be? What is H then? Let me do it here.
Equals to R.
See, this side force is P naught into area, and this side it is PCM into area. I have to
PCM.
equate these. Then I am getting P naught is equal to, or PCM is equal to P naught. PCM is equal to P naught. I don't know what is PCM, but I know plus rho G into R1. It is R1 radius. Rho G into R1. And then I will go up to, from here to here I will go. It will remain same. But then from here to here I will go up I will go. Minus rho GH. And it is again equal to P naught.
R1, sir.
P naught by balancing the forces.
R1, sir.
Equation 2 we are getting by applying what? By applying the equation of that integral of dp is equal to, that equation means which we simply say that pressure variation equation from one point to the other points. That is the second equation. By these two we are getting R1 is equal to H.
Okay, sir.
Okay. This one you do. Again same thing, but with a little slightly different means depth is again B. What is the width of this? If you want to go how much inside, it is B. B is the into the plane. Excuse me. Other than that, angle is given, density is given, density is rho of the liquid.
We will take screenshot and say tomorrow.
Right.
Yes, got
Then we can do that.
Oh,
Okay, tomorrow what we have to do? Tomorrow I have to do a number of this thing. Variable if multiple fluids are there, or variable density cases. Variable
Yes,
density
sir.
cases.
In finding force, sir.
Density cases I will take tomorrow. How to do for variable density cases? I have no option, but I will have to integrate. I have no other option. This case I have to integrate only. Number one, I will do before that torque on wall of dam. One case. Second case, variable density cases. Third case, I can take force by integration on curved surface area. Sometimes integration may be important, so you should learn integration also. Force by. This is not that much important because we already know the third part. Even if I don't do it, no problem. I can skip it. Force by integration on curved surface area. I can take it or I may skip it. But other than that, I think more important than three, there will be the syllabus headings. Whatever is given in the syllabus, like hydraulic lift, etc., manometer, barometer, all those things I will cover. Manometer, barometer, etc. These are just simple topics. Very easily these will be covered. But I have to cover these also, no? And also rotating cylinder cases. When cylinder rotates, then this liquid will become curvilinear. It will become its surface will become curved
Yes,
surface,
sir.
parabola
We can
surface.
observe.
I will have to explain this also. Rotating cylinder cases. So these cases I will do tomorrow. Just I write it here so that I can remember myself also. Okay, then fine. Let's send it here. Okay.
Okay, sir.
This you can attempt yourself. How to do this? I will give you a little hint here.
Sir,
You
already
have to
completed,
plainly
sir.
calculate. I think make a vertical area here. See, take this point here. You have to first locate this point here, and you have to draw vertical plane from here, vertical wall from here. And on this vertical wall, up to infinity, it may extend. Then imagine this liquid is filled up to this. So how much volume that liquid will occupy, that you have to see. Then whatever is the vertical force on this portion, that will be equal to the volume of liquid into density of liquid into G in this portion. Means it will be up to this portion also. That total. That is one thing. But how to find out, that is your concern now. I will not tell you. And how to find out the horizontal force? Horizontal, I think we can find out by just taking in that vertical wall and finding the projection on that vertical wall of this by horizontal rays. If I get the shadow, but not including this part, obviously, only for
Sir. Sir.
Sir,
Sir. Sir.
sir,